The heart of the animation-based game is a game loop. Every time the timer goes off, the timer listener class listens to the event and action performed is called. So action performed is the heart of the game loop. Game loop, first thing is everything on the canvas, try to move that for animation purpose, and then detect any collisions like snake is colliding with the walls or food and so on, and then redraw the canvas. Then overall we see the animation. So first thing to do as a collision detection is if a snake eats the food or not. So let's implement that. As a snake eats the food, let's make the snake body grow and then remove the food and then add a new food for that purpose. First, let's find where the snake is in the game figures on the canvas. We are assuming that there are lots of things to display. At this moment, we have snake only though. We are going to add the food, and as we extend the game, we may add the poison and the like, or barriers and the like. So let's first find where the snake is. For easy reference, let's have figures on the canvas. Figures is a game board, get canvas, get figures. That's the array list. And then let's find snake object first. Snake, null at the beginning, and then any figure and then figures. If f is instance of snake, that's it. And then snake, we know this is for sure snake, so we can do typecasting and then break the loop. Snake is from model there. So at this moment, if snake is still null, we don't find snake, so let's return, let's quit collision detection. The rest is meaningless. So let's find a snake versus a food. Let's detect that. As we detect the food, we are going to remove from figures array list. To do so, let's have a temporary variable, remove foods, new array list, game element. There. Array list is from Java util. There. Game element is from model. There. We are writing a general routine that at this moment we have only one food, but you may want to add many foods. Then this routine works regardless of the number of foods on the game scene. So let's do the looping for game figures on the screen. Then if this is an instance of snake, let's skip that part. Otherwise, snake collide with the element. So snake collides with one of the game element, assuming you have lots of other things as well. So we are writing general case. So if that is food, then we got the food. Then what you want to do is temporary variable, remove foods, add this one is a food that we are going to remove from the game scene array list later. Food is from model there, and then we are going to add another body and let the snake body grow. So get composite and add new snake body there, add another snake body. But at the very beginning, snake body should be hidden, and then as it moves, the location is updated accordingly. So let's take it outside the game scene. Snake body is from model, and then for next frame, the last element will be updated based on the currently the last element location. So let's hide from the game scene there. Then when everything is done, loop ends. Then if remove food size is positive, so at least one food is removed, then figures remove all and then provide an array list. So remove is to remove one element, but remove all is you provide another array list that all the elements in this array list will be removed from this array list. That's a remove all. And then all the foods are removed. So let's allocate another food, game board, create food. There, then new food will be created. So let's test this part. Run, start. Let's eat. The snake body grows. You can see the last one is unfilled. As we move, eat, the last one is filled. So to make it clear, let's have initial body size as 3 and run. So 3, add. Now I have a body size of 4, body size of 5. Food is randomly generated, random location. Now 6, 7, it continues to grow.